For nearly 30 years, there was only one undisputed king of the hybrid car. If you wanted insane fuel economy, bulletproof reliability, and a system that just worked, you bought a Toyota. They built a mechanical fortress that no other automaker could break into. But right now, a massive shift is happening over in China. Automakers are rolling out family sedans that claim to drive over 2,000 kilometers on a single tank. They are hitting fuel economy numbers that sound like pure science fiction, and they are doing it by completely tearing up the rulebook Toyota spent decades perfecting. This is a story of how Chinese engineers flipped the hybrid car upside down. Picture filling up a regular family sedan somewhere in Xi'an, China. You roll out of the gas station and hit the open road. The trip meter hits 1,000 kilometers, then 1,500, then 2,000. By the time you finally run out of fuel, you have basically driven all the way from New York down to Miami on one single tank. Here is the wild part though. The crazy thing is not just that the car pulled it off, it is what is actually sitting under the hood. No giant twin-turbo V8, no futuristic synthetic race fuel, just a tiny 1.5-liter four-cylinder making barely 100 horsepower, a completely standard, everyday Chinese plug-in hybrid. In 2024, BYD dropped the Kin LDMI, claiming an empty battery fuel burn of just 2.9 liters per 100 kilometers on the old NEDC test, alongside a total range of 2,100 kilometers. Independent testers pushed it even harder, with one test landing at 2.2 liters per 100 kilometers. That is nearly 107 miles per gallon. Let us be real here for a second, because you will not see 106 MPG on an everyday work commute. Under tougher global WLTC testing, real-world numbers sit closer to 3.8 to 4.0 liters per 100 kilometers, which works out to about 59 to 62 US MPG. That is still ridiculously impressive. And that gap tells an important story. Because this whole thing is not about some magic combustion trick. The real story is that Chinese automakers figured out a completely different playbook for building a hybrid. To understand why this is a massive deal, you have to look back to 1993. Toyota was taking on a monster project. The bosses wanted a true car for the 21st century, not just another facelifted Corolla, but something that would rewrite the rulebook on fuel economy. They called it Project G21. The target was brutal cut normal fuel consumption straight in half. The main headache with standard cars was pretty simple. A gas engine has to wear too many hats. It has to pull a heavy car from a dead stop climb, steep hills, cruise on the highway, respond instantly when you stomp the pedal, and sit idling in traffic because it has to handle everything. It almost never runs in its actual sweet spot. Toyota came up with an ingenious fix. Stop asking the gas engine to do all the heavy lifting and let electric motors carry the weight. They did not just slap a motor onto an engine. They built the Toyota hybrid system around a clever planetary gear set. Motor and wheels were all tied together mechanically through a power split gear. No old-school multi-speed gearbox shifting up and down. Instead, the system constantly balanced engine speed with road speed, keeping the gas engine right where it runs best. That layout gave us the Prius. It became the gold standard for bulletproof reliability and efficiency. For decades, everyone else tried to catch up, but Toyota had built an iron fortress of patents and engineering. If you wanted to build an efficient hybrid, you could not copy their layout. You had to find another way around. That exact roadblock is where the Chinese hybrid story kicks off. Toyota did not stay on top just because rivals were lazy. Toyota cracked a brutal engineering puzzle using pure mechanical simplicity and rock-solid durability. Real roads are not clean test labs. A car has to take freezing snow, blazing desert heat, missed oil changes, and hundreds of thousands of stop-and-go city miles. Other giants tried their own ideas. General Motors built a complicated two-mode hybrid with extra gear sets and clutches. Smart on paper, but a flop in showrooms. European brands went with P2 setups, dropping an electric motor between the engine and standard transmission. It worked, but ended up heavy, pricey, and overcomplicated. Honda built sharp two-motor setups, GM made the Volt, and others toyed around with mild hybrids and diesels. Still, nobody managed to knock Toyota throne. Why der 100? Because nearly every traditional hybrid still treated the gas engine as the star of the show. The battery and motors were just backup dancers, while the combustion engine stayed in charge. Then engineers in China started asking a totally different question. Not, how do we copy Toyota and do it better? Instead, why are we still forcing the gas engine to do the hard work in the first place? This is where things get really counterintuitive. The breakthrough did not come from adding horsepower. It came from stripping power away on purpose. BYD's DM 5.0 system runs a naturally aspirated 1.5-liter engine, putting out only around 100 horsepower. On paper, that sounds slow and boring. That is literally the whole secret. This engine is not built to win street races. It does not need instant punch off the line. It never has to react when you floor the pedal. The electric drive motor handles all of that heavy lifting. Around town, the car drives just like a pure EV. The battery feeds the motor turns the wheels, and the gas engine quietly chugs along in a tiny, ultra-efficient sweet spot. On the highway, when speeds level off, a clutch locks the engine directly to the drive wheels for smooth cruising. The entire mindset flipped on its head. The engine is no longer the star running back. It is just the quiet backup generator in the basement. The moment you stop making the engine react to every tap of the pedal, you can tune it for a single goal pure. Every gas engine is basically a heat machine. You feed in fuel, spark it, build pressure, push a piston, turn a crankshaft, and move the car. For decades, regular production engines wasted most of that heat out the exhaust, running around 25 to 35% thermal efficiency. Toyota pushed boundaries with their dynamic force engines, climbing up to about 40 or 41%. That was world-class territory. Then BYD dropped a number that shocked the entire auto world. 46.06% brake thermal efficiency. Keep this in perspective. That does not mean the car converts 46% of every drop of gas into pure speed every second you drive. That 46% represents peak efficiency on one exact sweet spot of the engine map. Because this hybrid layout keeps the engine sitting in that sweet spot way more often, the real-world fuel savings are massive. So how do you actually push an engine past 46% efficiency? It is not magic. It is a ruthless stack of smart engineering compromise. First, crazy high compression. BYD runs an ultra-high compression ratio of about 16:1. Squeezing harder extracts way more power from burning gases, but it usually leads to engine-destroying knock. To keep it safe, engineers use an aggressive Atkinson-Miller cycle teamed with heavy-cooled exhaust gas recirculation. Second, a long-stroke design. A longer piston stroke gives burning gases more time and room to push down, pulling out maximum mechanical force before the exhaust valve opens and throws heat away. Third, fully electric accessories. Old engines use rubber belts running water pumps, oil pumps, and AC compressors, constantly robbing engine power. Here, every single accessory runs on electricity, only turning on when truly needed. When you are chasing tiny fractions of efficiency, every little parasitic drag adds up fast. The real cheat code? The engine does not need to be great everywhere. It just has to be world-class at one steady speed. Think of an old-school gas car like one tired worker running an entire restaurant kitchen, cooking, taking orders, washing dishes, and bussing tables all at once. They burn out fast and waste energy. Now imagine telling that worker, you have one job: sit at this table and chop vegetables at a steady pace. That is exactly how this setup works. The electric motor takes care of the toughest fuel-guzzling moments, pulling away from a dead stop, crawling through stop-and-go jams, giving you instant passing power, grabbing back lost energy through regenerative braking. Meanwhile, the gas engine just hums along as an onboard power generator and highway cruise helper. This is not a gas car with a battery booster. It is essentially an electric car carrying its own compact generator. Let us revisit that wild 106 MPG headline. Did China really make traditional hybrids obsolete overnight? Let us check what the real data actually says. Those crazy numbers like 2.2 or 2.48 liters per 100 kilometers came from staged hypermiling media runs across flat Chinese roads. The official 2.9-liter claim was measured under the outdated NEDC cycle, which is notoriously easy on cars compared to real driving. On the stricter WLTC cycle, with a flat battery, real consumption lands around 3.8 to 4.0 liters per 100 kilometers. If you jump on an open highway, cruising at 75 miles per hour, with the air conditioning blasting, consumption goes up to around 4.3 to 4.8 liters per 100 kilometer. Even when you look past the marketing hype, the reality is clear. This is still an insanely efficient car. What about that massive 2100 kilometer range claim? It sounds impossible until you take a closer look at the spec sheet. The engineers did not just tweak the motor and engine, they quietly made the gas tank much bigger. The Kin L packs a 65-liter tank compared to 48 liters on the older model, which is an increase of more than 35%. That 2100 kilometer run is not powered by some miracle engine alone. It comes from a combination of high engine efficiency, a plug-in battery pack, electric first city driving, and simply carrying a lot more gasoline on board. The real win was not chasing a single party trick. It was about optimizing the whole car as one complete system. Smart engineering is great. Low prices are what actually shake up the world. You can invent the smartest hybrid on the planet, but if it costs 70 grand, it stays a niche toy for rich buyers. BYD launched a Kin L and Seal 06 starting right around 99,800 RMB, which is about 13,800 US dollars. Take a second to let that sink in. A roomy family sedan with a high-efficiency engine, an LFP blade battery, modern electronics, and full electric drive sells for the price of a stripped-down entry-level gas car. This is where China's true superpower comes in: complete vertical integration. BYD does not just piece together bought parts. They build their own battery, cells, motors, power chips, and wiring in their own factories. The future of cars will not be won just by whoever patents the coolest engine cycle. It belongs to whoever can manufacture complete electrified systems at massive scale for prices normal people can afford. This all ties back to BYD founder Wang Chuanfu. Back in 1995, BYD was just a 20-person shop in Shenzhen making phone batteries. By 2003, Wang made a move that looked crazy to car experts. He bought out a broken state-owned auto factory. Car veterans laughed at a battery outfit trying to build vehicles, but BYD had a secret weapon. They understood battery chemistry and electric motors down to the raw elements. Electric drive was never an afterthought or a government checkbox for them. It was baked into who they were. In early 2022, BYD took the gamble and completely stopped making pure gas cars. By ditching old-school engines, they stopped protecting legacy platforms. They built an electric chassis first and then dropped in a small specialized gas engine, strictly as a backup generator. They did not save the combustion engine by defending its old glory. They saved it by giving it a totally new job. Now we need to zoom out and look at the whole picture fairly. It is easy to read news headlines and assume Toyota is suddenly in trouble. Real-world evidence tells a very different story. Toyota has battle-tested its hybrid tech across 30 years and tens of millions of cars globally. Their standard hybrids never force you to find a plug to keep delivering great mileage. Toyota owns something lab tests cannot fake: decades of proven road durability. A 16:1 compression engine running tons of dirty exhaust gas is a brilliant piece of engineering, but it has not survived 20 years of freezing winters, bad fuel, skipped oil changes, and aggressive daily beatings across the world. The exact design tricks that make this system shine in city traffic create real compromises when the going gets tough. You are hauling up a steep mountain highway at 75 miles per hour with a completely drained battery. Under the hood sits a small 1.5-liter engine making barely 100 horsepower. Suddenly, that tiny motor has to drag a heavy car uphill while trying to keep the battery system alive at the same time. In that situation, the engine gets pushed way outside its comfort zone. Revs, screen performance falls flat, and fuel economy takes a beating. Tests show heavy high-load highway driving can push consumption up to 7.5 to 9.0 liters per 100 kilometer. That is a very different story from a slow city test loop. When you tune an engine by taking away its heavy duties, the second you dump those duties back on it, the efficiency edge disappears in a hurry. Beyond heavy hill climbs, there are long-term durability questions only time will answer. How will these ultra-high compression setups hold up after 15,000 miles? What about carbon buildup on valves, injector clogs, and catalytic converter wear from constant engine start-stop cycles? Then there is freezing winter weather. LFP batteries take a hit in sub-zero cold. On top of that, these super-efficient engines waste so little heat that the car might actually have to burn extra fuel just to keep you warm inside the cabin. These are not fatal flaws, they are just basic laws of physics you cannot dodge. Not entirely, but they permanently changed the playing field. Toyota's genius was never just about miles per gallon. It was mastering a mechanical gearbox that lasted forever at global scale. Chinese car makers did not bother trying to out-engineer Toyota's planetary gears. They moved the fight to an electric-first setup with a dedicated gas generator on board. This is no longer a battle between mechanical transmissions. It is a clash between old-school mechanical craft and software-driven electric setups. BYD is not working alone either. Geely launched its EMI hybrid, hitting 46.5% thermal efficiency, with new engines aiming past 47%. This is not a lucky shot from one brand. It is a massive coordinated push across the entire Chinese automotive world. This goes way beyond one car or one engine spec. China built an unbroken industrial supply chain covering raw lithium refining, battery cells, motors, chips, and final car assembly. Production of plug-in cars in China now runs in the millions every year. That insane scale creates an unstoppable loop. Massive production slashes parts costs. Cheaper parts drop window sticker prices. Lower prices bring in floods of new buyers. Bigger sales bankroll the next round of research. The biggest threat here is not just an engine running at 46% efficiency. It is the massive industrial machine manufacturing it. Simple as gas vs EV. For years, people talked about the shift to electric cars like a simple straight path. Old gas cars, then traditional hybrids, then full battery EVs. Real life is never that simple, where chargers are rare long-range plug-in hybrids solve range anxiety instantly, where trade rules or battery shortages slow pure EV exports, efficient hybrids bridge the gap. Where buyers demand decades of proven reliability, Toyota still holds incredible trust. There will not be just one single winner, but the baseline of what people expect from a hybrid car will never go back to what it was. Look back at that family sedan sitting on the test road. A small engine, an electric motor, a battery pack, a trip meter rolling past 2,000 kilometers. The flashy headline was 106 MPG, but the real lesson is way more interesting. For nearly 30 years, the car industry treated the gas engine as the main workhorse responsible for moving the wheels. Toyota became the master of helping that engine work alongside electricity. China flipped the script. They asked, what if the engine stops trying to be the hero? What if electric motors take care of all the stop-starts and hard pulls while the gas engine does one simple job with laser focus? The internal combustion engine is not dead yet. It just got reassigned to a brand new role. Not as the muscle, not as the headline star, just a super efficient power generator on wheels. If these cars hold up over the next 10 years in real drivers' hands, the biggest story will not be the death of the gas engine. It will be the day the gas engine stopped driving the car and became the machine that keeps the electric motor running. So as we look at where the automotive world is heading, the real debate isn't whether electric vehicles will eventually take over. The real question is what happens in the messy, decades-long transition in between. On one side, you have Toyota, 30 years of legendary engineering, near indestructible mechanical powertrains, and systems that just work without needing a charging plug. On the other side, you have China's new wave of automakers, rebuilding the car from the battery up, slashing production costs, and proving that an engine doesn't need to be powerful if it's smart enough to stay in its sweet spot. Now I want to hear from you. If you were putting your own money down today for a car you plan to drive for the next 10 years, would you put your trust in Toyota's proven, battle-tested mechanical reliability? Or are you ready to bet on China's ultra-efficient, electric-first architecture?